So in this video, we're going to look at solving a quadratic equation by completing the square when the leading coefficient of the quadratic equation is a 1. So when we developed the idea about completing the square, we identified that we had an x plus a by x plus a square, and this was the square for which we needed to complete the square. So what we want to notice is when we multiplied this all out, and we did x plus a squared, we got x squared plus 2ax plus a squared. And so our concept of completing the square, the technique that we developed for completing the square, required that the leading coefficient on the x squared term be a 1. So this first example, we're going to do an example where we start out with a leading coefficient of 1 on the x squared term. So rewrite the equation. X squared plus 4x minus 1 equals 0. And then I think the easiest way to do these is to take the constant term that you're starting with and add that to both sides, or subtract it from both sides, whatever you need to do to get the constant term over on the right. So in this case, I'm going to add 1 to both sides, which will get this equal to 1, so that we have x squared plus 4x. And this is really the thing we're trying to complete the square on. We're trying to figure out what needs to go here to complete the area of that little square in the bottom right corner that we saw in the previous video. What goes there? And then what we want to remember from the previous video is that the coefficient on the linear term is half of the number that gets squared to give us this area. In other words, we had something that looked like x squared plus 2ax plus a squared equaled, well, we didn't have it equal to anything. This was just the area of the square, and the idea was this 2a has to equal the coefficient on the x term, and if we divide both sides by 2, then we get the number that's squared to give us the missing area. So usually what you do is you just remember by repeated practice that the number that needs to get squared to complete the square is half of this coefficient on the x term. So I take the coefficient, I know I need to have it, and once I have halved it, I'm going to have to square it. So I'm going to take half the coefficient on the x term and square it, which is going to give me a 4. And then I'm going to take this area and I'm going to add it on to complete the square. And I can't just add something to one side without adding it to the other, so now I'm going to take and add 4 to the other side. So on this side I have completed the square. And what you have to ask is, whose square did I complete? Well, I completed the square that I get when I take x and I add 2 to it. So the thing that's going to go here is always going to be the number that got squared, because this number squared is what gives you the plus 4 in the previous line. Plus 2 times plus 2 equals plus 4. So this is the number that gets squared to complete the square. And then once I get it into this position, I want to recognize here that I can use the square root property. To solve this, I can take the square root of both sides and cancel this exponent of 2 to dig the x out of the parentheses. So once I've completed the square, I'll give myself a little room here. I want to take the square root of both sides using the square root property. And the moment I take the square root of the number, I know I need to put it plus or minus because I get 2 solutions. The square root cancels the squaring, leaving me with an x plus 2 equal to plus or minus the square root of 5. And then I need to subtract this 2 from both sides. So I'm going to get x equals, I'm subtracting a 2, plus or minus the square root of 5. And those are the 2 solutions. You really are looking at 2 solutions here. I could break them apart. I could say, hey, this is negative 2 minus the square root of 5. There's one of the solutions, and then negative 2 plus the square root of 5, there is the other solution. And if I were doing this in set notation, I would say x is an element of the set that contains these two things, negative 2 minus the square root of 5, comma negative 2, plus the square root of 5.